So good morning to everybody. First of all, it's a great pleasure to be here in this conference because I heard a lot of good things about it, and it's a good experience to be here these days. So the topic I brought here, it's not too popular, as you can see by the room. But because of that, I decided to study it in detail. So the title I gave it is to document or not document, that's the question. And I hope that at the end you'll have some more guidelines about what I think we can do, especially when we have agile projects and we are working with complex systems, okay? So how many of you had problems with documentation? Like you don't want to do it, but you need to do it. And if you do it, you end up spending a lot of time, wasting effort. It's inconsistent. So everybody, okay, that's the right room to be today. So I'm from Porto, from University of Porto. Krakow is even better than Porto, I can say. I'm here for less than 36 hours, but that's my first opinion. I teach in the University of Porto in the School of Engineering. This is my school. And where I teach, I do research on software. Basically, software. Many different topics I teach. And my research is basically started with design patterns that most of you know. So I belong to this awesome patterns community where Agile also came from and Wikis too. So somehow I blend these three faces of this community. And the overall umbrella for all these topics is software knowledge management. So we have software projects. There's a lot of ideas, of knowledge, of tacit knowledge, of informal knowledge that we need to preserve. And that can be transmitted using best practices. That's why I use patterns. Usually we need tools. Wikis were created exactly to spread knowledge about your projects. And Agile doesn't pay a lot of attention to documentation. So how we blend all of this together. As you know, software development is communicating and sharing knowledge and experience. We need to formalize information. Basically, we listen to the clients. We listen to our systems. We smell our systems, code smells, and we try to make it better. And how we make it better? By formalizing information. And at the end, it is code. I usually say stupid code that runs in a computer, okay? So basically, we communicate, we understand, we transform, we formalize in that information, that knowledge in code. At the end, we need to collaborate because the system is ready or about to be ready or a new release is ready. And we need to collaborate with the clients, inside the teams, and so on, so that we do this cycle over and over again so that we have at the end the system that we want. Agile brought to this cycle much more iterations, so much more feedback, much more shorter cycles. But basically, for me, software development is knowledge transformation. So if it is knowledge, there are a lot of people, I'm not one of those, that study knowledge management, formally, theoretically. Sometimes we don't like what they say, but this is a huge slide, but it's important for us to be in the same page. So they say that they know that knowledge is always in the head of experts. So we need to share, to make the experts sharing what they know with non-experts. So they need to communicate. This is one point. Another point is experts have a lot of information, of knowledge. So what we do, should we waste the time of our experts and making them transmit all they know to the others that don't know nothing? So it can be a waste, okay? So we should focus on essential. What is essential depends on the project. Another thing is each aspect doesn't know everything because he's an expert. He's expert on a specific topic. So he's not usually very general. So we need to make those experts interact with each other. That's why we are here in this conference. We are all experts in Java, but inside Java, there are many, many aspects that we are not so expert, at least, okay? Another thing is, and this is very important, that's why we like to be in this conference, there's a lot of knowledge that is not able to be transmitted because it is tacit. When I say tacit, it means that it only emerges when we talk with each other. So we don't know that we know. But once we face people, once we talk with people that don't think that topic, that piece of information is trivial, oh, at that time, I know that topic, okay? So this tacit information is something that arises in conversations, for example. Face-to-face is the better one, of course, but it's expensive because it's not easy to transmit, to do conversations one-to-one in every situation. But it is very important in software, okay? So another thing is experts are very busy because they have a lot of value. And knowledge also has a shelf life. It means that it is created, it evolves, and must be maintained. So there's a cycle around this. So this is a little of theory of knowledge management, okay? Knowledge in general. I'm applying this to software knowledge management. So for me, understanding, and not only for me, is not possible to be stored only in documents. So we need conversations too. Actually, some experts say that the docs only contains 15 to 25% of the knowledge of a complex system. And I'm here focusing on complex systems, complex software systems. Complex because they are huge or because they are hard to do it, okay? Can be small, like software to land an airplane, but so not to millions lines of code. Otherwise, the bugs may be there in a very huge amount. So it is complex, and complex systems usually need documentation, but there's also a lot of information that is not there, okay? So this is the problem. This cycle is well known as the BAC concept, and basically it tells you, it's not related with software, it's related with knowledge in general. It comes from Toyota Production System, people from Japan, and basically it tells you the cycle of knowledge. It tells you that one person meets another person, that's here. So one person meets another person, they create, when they socialize, like here in the conference, we create common knowledge, okay? Then we need to externalize that knowledge to other people. For example, when I return home, probably I will tell the experience I have here, and so on and so on. And you will share with your people in your companies, and so on and so on. So we externalize that knowledge, and then we combine people that probably went to several conferences, different conferences in your organization. And finally, the person internalize, each one of us internalize that knowledge, and the cycle continues again, okay? So the faster we do this cycle, the more knowledge we create and evolve. So this is theory, okay? You know, in Agile, we don't pay attention to many practices, but you all know that Agile is not the silver bullet. When I teach Agile to my students or to professionals, basically I tell them it's not Agile that matters, it's how much Agile can you be in your project, in your product, in your organization. So, and I know that if you can be a lot of Agile, the better, because it will be more fun, more motivative, you have less resource wasted, and so on, okay? So, like in Agile, you should balance how much agility can you have. And I want you to have the maximum agility as possible, but you should succeed in your project. So the trick is to inspect and adapt, to analyze always many different things like capabilities, communication, knowledge, practices, documentation, formalities. So we have like a wave that we should monitor, and we have a lot of buttons that we can control. So the wave is there, what you try to inspect, and you adapt in these buttons. If the people don't communicate the knowledge they have well, we should increase documentation and formalities and so on, okay? So if you already communicate very well. You have high quality in your product, and the knowledge is there, so you don't see that you need more knowledge. Probably you can reduce documentation. Probably you can reduce formalities. Probably you don't need to have such a formal process in roles, artifacts, and tools, okay? So my point here is you should be as agile as you want, as you can, as your project enables you. And in terms of documentation, you should reduce documentation to a minimum. But usually in complex systems, that minimum is not zero. That's my point here, okay? Do you agree with me? Okay, let's go. So the problem is how to document without documenting. Software documentation is good, you all know, but it's hard and costly, and it's very boring. I didn't write that here, but it's very boring for many people. But every project benefits with good documentation, of course. But each project is a case. Simple and small projects may require only a few documentation or zero documentation. But systems that are complex, somehow you need to reuse them inside the team, inside the organization, or between organizations. So, and those you can't survive without explaining how to use those systems if they need to be reused, okay? So that's my point. But I also know that nobody reads documentation. So I was very excited when I saw this magazine, this article in the magazine, Practical Programmer. So people don't read documentation, usually. So only when we really need it. So inspired by, this problem is not new in software. So people that study this John Carroll is from Psychology of Learning. He decided to study the topic, and he created a methodology that's called Minimalist Instruction. It's very old, but actually is the base for the new user manuals of HP printers, for example. So they don't explain you so much, but you can survive. So minimalist instruction in 2 words is to explain only 50% of what you need to, what you want the person to know, okay? And create the curiosity so that people go get the other 50%. Something like that. This is short words, of course. So inspired by minimalist instruction and agile modeling from Scott Ambler, I analyzed, tried to synthesize all the processes related with documentation. And we found that we have authors of documents, we have readers, we have managers, we have tools. There's a setup process in beginning. There's a production process, which is writing the code, in this case, writing the docs. Organize them so that you have the folders, the connections between them, the links, whatever, depends on technology you are using. And you should store them. It can be in a GitHub, for example, or a Git. And once people use them, we should have analytics on the topics that are more important, the documents more important. And from that feedback, we maintain the documents and so on and so on. So probably we should treat documents as knowledge that is not written in a programming language, but is written in a native language, okay? And the cycle is very similar to what we do in software, in coding, exactly the same. But sometimes we don't pay attention to this. For example, I don't think very natural to have a programmer writing technical documents. What I think natural is to have a programmer telling a technical writer to write what he needs to be, has to be written, okay? So sometimes in our organizations, in our teams, we don't pay attention to this distance between coding and writing, and we end up having unhappy people and not such a good quality. So the best practice of this basically tell you, this is based on a paper on these topics. So if you, after mining many patterns of documenting without documenting, let's say, we found that this is the process you should follow. So are you documenting? To who? Who will read those documents? Who needs that knowledge, that information? So you should define the target audiences, okay? Based on that, try to understand the minimal they need. And then you start organizing the documents. So by defining the documents you need for the person, you are starting to have a an index of files, an index of documents, okay? Then you should publish them, so write them and publish them, of course. Then you should create and basically to have some support tools to present them to. An important aspect of this kind of documents of software is that we should have a lot of hyperlinks between them, so links between the files. That's why we prefer HTML or Markdown or web technology. But when you have links between docs and docs, that's okay. But sometimes we need to have links between docs and source code. And when you have links between docs and source code, it's a nightmare because you jump from one text file to a huge, possibly a huge code file. So sometimes we prefer to have a sample of that code, a fragment of code, inside the text. And when that happens, you can do copy-paste, and that copy-paste will be not updated anymore in the life of the document. So it will be out of date soon. Or you can have what we call transclusion. Transclusion is a kind of dynamic import of code inside the text, okay? So these are some best practices of how to document. Agile documentation basically is inspired in agile practices. You should create simple documents, just simple enough. There is this ideal of starting a document and completing the document immediately. But no, just create a simple document and start from there. Don't be ashamed of if it is too simple, okay? So it should be brief and doesn't need to have literary quality like you are an author of a novel. Just be very simple and precise, okay? And then you can create, also another practice is to create several documents at once. So instead of starting one document and concluding that document, just open, start creating any documents when you want, when you need them. Basically, when you need them, okay? That's why wikis are very good. You just start a link and then you follow the link or not. But the link is there ready to be completed. So another thing is documents, don't be ashamed of your documents because they are simple, they are not complete, but they are there. Just publish them publicly. Publicly means inside the team, inside the organization, or public if it is open source, okay? So don't be afraid of that because the usage of these documents will help you improve the documents as you go. So this is a very important aspect of this. And again, wikis are like this, okay? And then go there and document and update only when you need. So if you think that you'll need to write about something one day, wait for that one day, okay? So don't document before you need, otherwise you will waste time. The problem is sometimes if I don't document today, I will lose this knowledge, okay? So that's the day you should write. So when you need depends on many things. And then you should reuse documentation. Additional practice is to use simple tools and to define some standards. Otherwise, you can't allow many people documenting simply and using the same writing style as other people, okay? And finally, this is a very important one. Sometimes we don't document to share with others. We document to understand how we did things. So like, because when you document, when you write or talk, you verbalize, you use part of your brain that is different from only coding. And to write for yourself is a good practice. Although it is not essential, it is a good practice. So this was about how to document, basically to use Agile documentation. And Agile documentation is a set of practices that are very similar to Agile programming, so programming in Agile, but applied to this. So what should you document? Should you add comments inside your source code? No, I don't think so. This is about internal documentation. So internal documentation is limited to low-level comments or information inside your code. And with refactoring, with nice design, legibility, and so on, usually we like to reduce this internal documentation to zero, literally zero. When I see some doc comments inside, not the Java doc comments, but other comments, I don't like it because it seems that the person is not comfortable with the code he wrote. So what about to spend some more time making it better, okay? So I'm not telling you to document with comments inside Java files. But there are a lot of other knowledge that can't fit inside source code. These are basically design decisions, like why I apply this design pattern instead of the other. That doesn't fit inside one file. It should be several files. So these design decisions, architectural decisions, and other important decisions that do not fit inside one source code file should be documented elsewhere. And so that's this kind of documents that I'm telling you about. This is not to make you scared of, but there are many documents we do. And basically, these are the source code, so the private part. So when we have open source, or these are APIs, protected view, public view. It can be another API, but that's more public. But then we have information about design. We have information about architecture in components. We have information about the domain of the application. We have information general of all the software system. And what you have here are documents. Some documents are very specific. Other documents can cross many layers. And those documents usually are examples. That's why we love examples, because once we see an example, we go from an overview to the source code, okay? So these are simple examples. But there are more things that are important, like design notebooks. They don't go from overview, but they go from design level to another level. So usually you have documents, all of them, you know the names. And those documents are important for different kinds of usage of systems. But for complex systems, we may need a few of them. You don't need all of these, okay? So that's not agile. Just only to see that this can be very complex. So which documents should you write at least? If you have a complex system, that it should be reused. So you should start with a documentation roadmap. So it's a kind of index that may have an overview of the system. In this case, I call it a framework. Then you should have a spiral cookbook, which is a collection of how-tos. So it should start with how-tos that are very simple tasks to how-tos that are very, very complex or very detailed, okay? And then in this spiral cookbook, in these recipes, the how-tos, usually you use several examples. And those examples should also be from a kind of hello world, so very simple, to the complexity you may need. And then from those examples, you explain how are you reusing your system. So usually you go here from internal design level, okay? So can I use this for what? To do what? And that what can be defined here in customizable points so that you can see this huge system. For example, Swing is a framework for, what is Swing? Swing is a framework for building visual interfaces. How can I use Swing? Which kind of things can I do with Swing? We have buttons, we have windows, we have borders, and so on, okay? So customizable points are important aspects that are general. And usually each customizable point can go, if you want to explain how this works internally, you go to the design internals of this. And the design internals usually take advantage of design patterns, okay? So you have one part that use, for example, border factory. It's a factory. What is a factory? People know, other people may not know. But the document should have a link to the factory class or factory methods, and then explain that. So if you start this documentation roadmap, a small overview, which is usually 1 paragraph, 2 paragraphs. Then you go a series of how-tos. Then from those how-tos, you point to examples. In those examples, you have text and code. The code usually explains how it was customized, how it is customizing the framework, the system. And from then, you can go even in more detail to the design of the system, where you recur usually to design patterns. You don't need to document design patterns because they are public. You just point somewhere. in the case that you are using your own design patterns in the organization, you should write about them, okay? Of course, this is really nice if you have the examples with traversable code, which means that you can have a text, an HTML file, for example, or a wiki file, where you can go to the code and go back from the code to the text and so on. So hyperlinking of this, instead of having only copy-paste or flat source code files, okay? So you can navigate in the code, and you can, as you can navigate in the IDE, or you can navigate in a wiki page. Of course, in order to make this easy to find things, we have a reference guide. So it's a kind of index where you can go there and search immediately, okay? So this is minimal you should write. The error recovery guide is also nice, but today we have Stack Overflow, for example, and Google, and that will help us to find our problems. This can be a kind of frequently asked questions or common errors of using a system. Okay, are you with me? So there's an example. You all know this example. This is a very simple example, but explains you how to do this. I didn't wrote this documentation, okay? This is written, this is official version 3, so it's an old version, written by Kent Beck, okay? So we have here an example, an overview. Well, you can't read, but it says here what is JUnit, explains briefly what is JUnit, only this, okay? Then it says, points to other documentation, and has here the roadmap, the index. What can you, I'm sorry, this is too small for you to see. But here you can see all the documents that are relevant to this. So this is the roadmap. Then in that document, you can have several cases. In this case is a how to write a simple test case, and explains here very shortly how to do this. Of course, it has code, and in this code, it points to patterns sometimes. This is, for example, the design, all the design notebook of JUnit. It's very simple scheme of 7 classes, right? 1, 2, 3, 4, 5 classes and 7 patterns. So it has a lot of patterns inside. So if you look only to the source code, you can't see the patterns that are instantiated there, because otherwise the person, the author, in this case Kent Beck, wrote this class instantiates this pattern. It is not written there, so you can't see it, okay? The quality of the projection could be better. That's what here I can see better. Anyway, so this is the design notebook. Here it explains step by step. If you want to learn why this system, in this case JUnit framework, was designed, it is explained here in a short document, okay? So this is a design notebook. You don't need to know this to use JUnit. But if you want to do a similar JUnit or integrate or extend JUnit, you need to know this internal design. So we are going lower and lower and lower until the design. And after that, you see the source code, of course. But source code usually is not enough to explain you this. So you can read all of this like in 1 hour. And if you didn't read before, just read it whenever you want. Or whenever you need, because you'll see much more of the source code of JUnit. Of course, JUnit, we usually never extend. Did you extend JUnit for something? You see, nobody. But I did it, that's why I found these documents interesting. But in systems that you use, that you reuse, usually need this kind of documents. And this is an example. We love examples. So which kind of tools do we have to support this? Wikis were created to share knowledge about software, in this case, design patterns. So the problem we have with the current tools, is that we have heterogeneous documents, which means that a document is not only text, it's models, and it can have code as well. Because we are smart, we know that if we copy-paste code to a document, like, say, a Word document, I'm not suggesting Word documents, but let's suppose that we copy-paste code to a Word document or a Markdown. Because we are smart, we know that that code will be outdated very soon. So we don't do that. So we prefer only write text in a file and code in another file. And because we are smart and we like to not waste effort, these will be disconnected forever, okay? And that's not good. So it would be ideal to have a file where you can mix all these kinds of content. Sorry, source code, models, and documents. So we call this heterogeneous. But we have a problem. One of the problems is how to integrate this, how to synchronize those. Okay. JavaDoc, for example, is a good example of a small example of using literate programming, which is we have a file that is Java, we have a processor that extracts the code. In this case, doesn't extract the code, but it extracts the documents to produce a web document. Okay, so it's single source approach. The other approaches that are being used in other tools, more sophisticated, it can be like this. So you have Java files in one side, you have documents in another side. They point to each other. Usually the docs point to the code. And you have a tool which is an integrator that can produce the documentation based on both. So it's not only based on code, but based also on docs. And that tool can produce the PDF or the HTML, whatever, okay? Usually I prefer to produce web pages. So we start this idea with a wiki. It was a very simple one, where we write a small text that says which code we want to import here, and it will import, okay, dynamically. If you do refresh, it will go to the source code repository, like Git, and extract that small part and puts there. It can do the same for UML diagrams, but UML depends on technology used to produce UML. I'm not producing UML too much, so usually I use photos of whiteboards, and that's usually good enough. We evolved this to other wikis. And right now we are evolving another one, which is a wiki. Okay, wiki with a EA, which is a weekly typed wiki. So basically it's a wiki that is not only flat pages, but each page has a type. So let's go shortly to that. So it allows you to do transclusion of code. So it's not copy-paste of code, is using dynamic references to code, which means that the code will be always alive. Once you refresh the page, it will go get the original source code. It can be from a commit, a specific commit, or can be the last version of it, okay? And we have pages that can have types, and we have scaffolding, so you can evolve documents from previous documents, so templates. It helps a lot to do that. You have content assist, because when you are coding, you like to have sometimes code completion and suggestions for parts of code that you should write. And also when we are writing documents, we want the same. We also have the possibility of traveling in time in all the wiki. This is a wiki. But instead of traveling in a version of a file, we can travel in all the wiki. And another thing that is very important, we have the team awareness. So we have people that can be subscribing pages, and so they know when these pages change, probably my code must change or something closer to that. Right now, this is under development with our research group in the University of Porto with students. So we have many plugins already done. These are only a few examples. And right now we are compiling all of them in DokuWiki. Do you know DokuWiki? So it's a very famous wiki. And we are compiling all the things we did as a big plugin for DokuWiki so that we don't need to reinvent the wheel and create a wiki. We just are extending the wiki. One of the features we have there is, like in Google Docs, you can write documents in real time together in collaboration, which also helps. Well, on purpose, Genki, is that how I say? In Portuguese, we say obrigado. On purpose, I I think we have still some minutes, so that if you want to have questions, I'll be ready for them. So the question is, to document or not document? Well, it depends on your project, of course. But I suggest many complex projects need at least some documents. Okay? Thank you.